Continuing our discussion on partial fraction decomposition, I'm going to pick up where we left off in part 1 of section 10.7. So to find partial fraction decomposition, what we talked about in our last video is that we need to first factor our denominator completely, and our goal is to write this single fraction as the sum of smaller fractions, and each of those fractions contains a single factor of our original denominator. So here my first fraction would have a denominator of x plus 2, my second fraction would have a denominator of x minus 1. I then add the two fractions, but what I don't know is what the numerators would be. So since this first denominator has a degree of 1 for that factor, I'm going to have just a with a degree of 0, so no x's in that numerator. And then same thing for my second fraction. This is x to the first, so b, and then x to the 0, or just b. Now to solve for a and b, I'm going to eliminate all my fractions by multiplying everything by the LCD. And then I'm going to match coefficients from terms on the left to terms on the right. So on the left, I multiply by x plus 2 times x minus 1. And on the right, I have to multiply everything by x plus 2, x minus 1. On the left, the entire numerator and denominator cancel, so I've got 8x plus 7. And on the right, the x plus 2's cancel, leaving me with a times x minus 1, plus, and then for b, the x minus 1's cancel, leaving me with b times x plus 2. Now I want to match coefficients, so the coefficient on x is an 8, which means on the right-hand side, I need to find what the coefficient on x is. So I'm going to first distribute my a so that I can free up the x's. And also I will distribute my b. Then, since I want to match the coefficients on the left and the right, I'm going to compare the coefficients on x. So I'm going to group my x's and then factor out the x. So that would be x times a plus b. So I just grouped the ax and the bx together. And then I have x to the 0, so minus a plus 2b. So the coefficient on x on the right is a plus b. The coefficient on x on the left is 8. So my first equation is a plus b has to be 8. That way I have an 8x on the right-hand side. And on the left-hand side, my constants, or the part with no x's, has to match the constants, or parts with no x's on the right. So that means that the negative a plus 2b has to be 7. So that means I would have x times 8 plus a 7, which would match the 8x plus 7 on the left-hand side. Now we solve the system of equations. So I see that elimination will work very nicely here. So I'm going to add the 2, giving me 3b is equal to 15, which means that b is 5. We then can plug that in, so I'll plug that back into the first equation. A plus b is 8, a plus 5 is 8, which means that a is 3. So what we have found is that if I start with my original fraction, 8x plus 7 over x plus 2, x minus 1, I can decompose that into a fraction of denominator x plus 2 and denominator x minus 1, where a is the numerator on x plus 2, so that would be a 3, and b, which is 5, is the numerator on x minus 1. So the partial fraction decomposition of my original expression is 3 over x plus 2 plus 5 over x minus 1. In the second example that we have, we are going to need to first factor the denominator so that we can set up our form for partial fraction decomposition. So in factoring, I'm going to get x over and then x plus 4 times x minus 1. Now that it's factored, I'm going to ask you to go ahead and take it from here. So pause the video and practice decomposing this fraction on your own, and I will join you in a moment. So my first two denominators are x plus 4 and x minus 1. And my numerators, since my denominators only have degree 1, are going to be a and b. Multiplying by x plus 4 times x minus 1, the denominator will reduce completely. Here I multiply by x plus 4, x minus 1, and I will watch as the x plus 4 reduces. And my third fraction, x plus 4, x minus 1, the x minus 1 will reduce, leaving me with, on the left, x equals, on the right, a times x minus 1 plus b times x plus 4. And since I want my coefficients to match, I'm going to distribute on the right so that I can regroup my x terms and my constant terms together. So on the left I have an x, which is equal to, on the right I'm going to group my x terms and factor out the x so that the coefficient is a plus b. And then my constant terms are negative a and a positive 4b. So the coefficient on x on the left is just a 1. The coefficient on x on the right is a plus b. So that tells me that a plus b has to equal 1. Then my constant term on the left, there is none, so I can think of that as a plus 0. And my constant term, or the part with no x's on the right, is negative a plus 4b. So I've got negative a plus 4b, which would equal 0. So doing that, a plus b is 1, so I have 1x plus 0, which matches the left-hand side. So now this is a good opportunity for me to, again, use elimination. So I'm going to simply add, and the a's will cancel each other out since they're inverses. So I've got 5b is equal to 1, which means that b is 1/5. Going back to find a, I'm going to use the first equation. A plus b is equal to 1. So a plus 1/5 is equal to 1, which means that a is equal to 4/5. So then my partial fraction decomposition is a over x plus 4 plus b over x minus 1. A is 4/5 over x plus 4, and b is 1/5 over x minus 1. Now, since we have a fraction, what I'm going to do is simplify this by actually multiplying the numerator and the denominator by 5. What that's going to do is it's going to cause my 5's to reduce so that I don't have that ugly fraction anymore. So I will have 4 over, and then I distribute to get 5x plus 20, plus, and then the same thing on the right, I'm going to multiply by 5 in the numerator and denominator so that that fraction in the numerator reduces, and I just have 1 over, and then I distribute to get 5x minus 5. So the partial fraction decomposition of x over x squared plus 3x minus 4 is 4 over 5x plus 20 plus 1 over 5x minus 5. Go ahead and take a moment to pause the video and try completing this partial fraction decomposition on your own. My first step is going to be, of course, to factor the denominator, so x minus 25 over, and then factoring, I get x plus 8 times x minus 3. So my two fractions are going to be a over x plus 8 and b over x minus 3. So multiplying by the LCD, x plus 8 times x minus 3, and then I'll multiply everything on the right by x plus 8 times x minus 3. The entire denominator on the right reduces, so I've got x minus 25. And on the right, when I distribute to a, I've got a times x minus 3 because the x plus 8's reduce. And when I distribute to my b, my x minus 3's reduce, leaving me with b times x plus 8. Distributing so that I can compare my coefficients, I've got ax minus 3a plus bx plus 8b. And then I need to compare my coefficients. So to do that, I am going to regroup. So I've got a x plus bx minus 3a plus 8b. And then my coefficient on x on the right would be a plus b when I factor out that x. And then on the right, I also see that the constant term, or the component with no x, is going to be 3a plus 8b. So I'm going to match my coefficients on the right and the left. Coefficient on x on the left is 1, which means that a plus b on the right has to be 1. So there's my first equation. My constant term, or the piece with no x on the left, is negative 25, which means that the piece with no x on the right, negative 3a plus 8b, would have to be also negative 25. We can solve this in a number of ways. I do think that using elimination is going to be the most straightforward again. So I'm going to multiply that entire first equation by a positive 3 to get 3a plus 3b is equal to 3. And when adding, I get 11b equals negative 22. So b is a negative 2. And then I'll go back in and plug that in for the b in my very first equation. So a plus a negative 2 or a minus 2 is 1, which means that a has to equal 3. So then going back to my original partial fraction decomposition, a over x plus 8 plus b over x minus 3. When I substitute a and b in, I find that the partial fraction decomposition is 3 over x plus 8 minus 2 over x minus 3. And this would be our partial fraction decomposition for our original expression. For our last example, this one does change a little bit because we have a factor of a multiple greater than 1. So I must make sure to write this as a sum of all factors. So my first denominator is x. My second denominator would be x minus 1. My third denominator would be x minus 1 to the second. And my fourth denominator would be x minus 1 to the third. So I've accounted for all powers of that x minus 1. This factor is x, so my numerator is going to be just a with no x's, then b. Here, inside those parentheses, I've got a degree of 1, so this would be a degree of 0, and same thing for that fourth fraction. And then we multiply by the LCD and solve for a, b, c, and d. Multiplying by the LCD, the denominator on the left reduces, and I'm left with x squared plus 1. And then I distribute and reduce on the right. For my first term a, the x reduces. For my second term b, one of the factors of x minus 1 reduces, leaving me with an x and an x minus 1 squared. For c, two of those factors of x minus 1 reduce, leaving me with an x and an x minus 1. And for d, all three of those x minus 1s reduce, leaving me with just d times x. Then I'm going to simplify this entire right-hand side so that I can match coefficients. Now that I've multiplied everything out, I need to group everything so that I have common factors together. So that would be ax to the third and bx to the third. I've got x to the second, x to the second, x to the second. Here I've got x, 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 and then my constant term is only a. Once I get here, I then match coefficients. So my a plus b is a coefficient on x to the third, but there are 0 x to the thirds, so that means a plus b has to be 0. The coefficient on x squared is a 1, which means that negative 3a minus 2b plus c has to equal 1. There is no x term, which means the coefficient on x is 0, so 3a plus b minus c plus d is equal to 0. And then my constant term, which is a, or negative a, would have to match my constant term, which is a positive 1. You can solve this in a number of ways, but I think back substitution is going to be the easiest, so I'm going to go ahead and do that here. So I found my values for A, B, C, and D, and then I can write my decomposition. That's the end of our video. Thanks for watching.